electrical metallic tubing, or EMT, is indeed acceptable for use under a mobile home to provide both flexibility and protection for the feeder connection, given that several key requirements are rigorously met. These requirements encompass size, length, support, grounding, proper transitions, and protection against physical damage and moisture. Firstly, concerning size, the EMT must be adequately sized to accommodate the electrical conductors it will house. This involves calculating the cross-sectional area of all conductors, including neutral and grounding wires, to ensure they do not exceed the full capacity of the chosen EMT conduit size. The National Electrical Code, or NEC, provides tables, such as those found in Chapter 9, that detail the maximum number of conductors permitted in various conduit sizes. The selection must also account for future expansion, if anticipated. Secondly, regarding the length limitation, the segment of EMT used in this application should not exceed 6 feet in length. This restriction is in place to maintain the necessary flexibility while minimizing potential issues related to voltage drop and impedance. If the distance between the underground PVC conduit and the connection point in the mobile home exceeds 6 feet, an alternative method, such as using a flexible metal conduit, may be more suitable, provided it meets all other applicable code requirements. Thirdly, the EMT needs to be securely supported along its entire length. Proper support ensures that the conduit does not sag or become displaced, which could compromise its protective function and potentially damage the conductors within. Support should be installed at intervals not exceeding those specified in the NEC, typically around every 3 feet and within 1 foot of any box or fitting. The support should be designed for use with the EMT and securely fastened to the mobile home's frame or a suitable supporting structure. Fourthly, proper grounding of the EMT is crucial for electrical safety. The EMT serves as a grounding conductor and must be effectively bonded to the mobile home's grounding system and the incoming grounding electrode conductor. This can be achieved by using approved grounding lock nuts and bushings at each connection point, ensuring a continuous and low-impedance ground path. It is important to verify that all fittings and connectors are listed for grounding purposes. Fifthly, the transition from PVC conduit to the EMT and then back to PVC conduit must be executed using approved fittings and adapters that are specifically designed for this purpose. These fittings should provide a secure and watertight connection to prevent moisture from entering the raceway system. When transitioning from underground PVC to EMT, a suitable adapter should be used to protect the EMT from corrosion due to contact with the soil. Fittings must also maintain the integrity of the grounding path. Sixthly, and finally, the EMT must be adequately protected from physical damage and moisture. Given its location beneath the mobile home, it is susceptible to impact from debris, corrosion from exposure to the elements, and potential damage from rodents or other pests. To mitigate these risks, the EMT should be installed in a manner that minimizes its exposure to these hazards. This may involve using a larger size EMT for added mechanical strength, providing additional physical barriers, or applying a protective coating to prevent corrosion. Furthermore, all connections and fittings must be watertight to prevent moisture from entering the conduit system. In summary, the use of EMT under a mobile home for feeder protection is permissible, provided these 6 key conditions are satisfied: size adequacy, length constraint, secure support, proper grounding, appropriate transition fittings, and robust protection against damage and moisture. Adherence to these requirements ensures a safe and code-compliant installation. It is also vital to consult and comply with all applicable electrical codes, standards, and local regulations, including the NEC and any specific requirements imposed by the local authority having jurisdiction, or OJ. An electrical inspection is always recommended to verify compliance and ensure the safety of the installation. Remember to consider any potential for future modifications or upgrades to the electrical system. Oversizing the EMT slightly can provide flexibility for adding circuits or increasing conductor sizes in the future. This foresight can save time and money in the long run. When selecting fittings and connectors, choose those that are specifically listed for use with EMT and that are suitable for the environmental conditions. Using the correct fittings ensures a secure and reliable connection. Take precautions to prevent damage to the EMT during installation. Avoid bending it excessively or subjecting it to undue stress. If the EMT needs to be bent, use a proper conduit bender to avoid kinking or flattening it. Regularly inspect the EMT and its connections for any signs of damage or corrosion. Address any issues promptly to prevent them from escalating into more serious problems. Keep a record of the installation, including the types and sizes of materials used, the locations of connections, and any relevant inspection reports. This documentation can be helpful for future maintenance or modifications. It is also essential to ensure that the work area is safe and that all necessary safety precautions are taken. This includes wearing appropriate personal protective equipment, or PPE, such as safety glasses and gloves, and energizing the electrical system before beginning any work. Following these guidelines will help to ensure a safe and compliant installation of EMT under a mobile home for feeder protection. Always prioritize safety and adhere to the applicable electrical codes and standards. And, if you're unsure about any aspect of the installation, it is best to consult with a qualified electrician. The NEC is updated regularly, typically every 3 years, so it is important to use the most current edition when planning and executing electrical installations. Changes and revisions to the code can impact the requirements for EMT installations, including conductor fill limitations, support spacing, and grounding methods. Familiarize yourself with any local amendments to the NEC that may be in effect in your area. Local jurisdictions often have their own specific requirements that supplement or modify the NEC. Ensure that all electrical components used in the installation, including the EMT, fittings, and conductors, are listed by a recognized testing laboratory, such as Underwriters Laboratories or OL. Listing indicates that the components have been tested and meet established safety standards. Pay close attention to the ampacity of the conductors used in the EMT. The ampacity is the maximum amount of current that a conductor can safely carry without overheating. The NEC provides tables that list the ampacities of various conductor sizes and types. Make sure that the conductors are properly derated if they are installed in a raceway with multiple conductors. Derating reduces the ampacity to account for the heat generated by multiple current-carrying conductors in close proximity. When installing the EMT, be mindful of potential sources of electromagnetic interference or ME. Running the EMT parallel to power lines or other sources of EMI can induce unwanted currents in the conduit. In some cases, it may be necessary to use shielded EMT or to take other measures to mitigate EMI. Consider the potential for condensation to form inside the EMT. Condensation can occur when warm, moist air comes into contact with a cooler surface. If condensation is likely, use a conduit sealant to prevent moisture from entering the EMT. Ensure that the grounding electrode conductor is properly sized and connected to the grounding electrode system. The grounding electrode system provides a path for fault current to return to the source, helping to protect against electrical shock. Use appropriate methods to protect the EMT from corrosion if it is installed in a corrosive environment. This may involve using a corrosion-resistant coating or selecting a different type of conduit material. When making connections to electrical boxes or enclosures, use proper bonding bushings and lock nuts to ensure a continuous ground path. Bonding bushings and lock nuts are designed to provide a secure and reliable connection between the EMT and the box or enclosure. Clearly label all electrical panels and circuits to make it easier to identify and troubleshoot problems in the future. Labeling helps to prevent accidental contact with live circuits. After the installation is complete, thoroughly test the electrical system to ensure that it is working properly and that all safety devices are functioning as intended. Testing should include checking for proper voltage, continuity, and ground fault protection. Keep a copy of the electrical permit and inspection reports on file for future reference. The permit and inspection reports provide documentation that the installation meets the applicable codes and standards. If you are not comfortable performing the electrical work yourself, hire a qualified electrician to do the job. Electrical work can be dangerous, and it is important to have it done by someone who is trained and experienced. Obtain all necessary permits before beginning any electrical work. Permits are required to ensure that the work is done in accordance with the applicable codes and standards. Inform the local utility company of any planned electrical work that may affect their equipment. The utility company may need to de-energize or isolate their equipment to allow the work to be done safely. Before digging underground, contact the local call center to have underground utilities located and marked. This helps to prevent damage to underground utilities and ensures the safety of workers. Always disconnect the power before working on any electrical circuits. Disconnecting the power helps to prevent electrical shock and electrocution. Use caution when working around water. Water is a good conductor of electricity, and it can increase the risk of electrical shock. Avoid wearing metal jewelry when working on electrical circuits. Metal jewelry can conduct electricity and increase the risk of electrical shock. Use insulated tools when working on electrical circuits. Insulated tools help to protect against electrical shock. Never work on electrical circuits alone. Having someone else present can provide assistance in case of an emergency. Be aware of the potential hazards of arc flash. Arc flash is a dangerous electrical explosion that can cause serious burns and injuries. Use appropriate arc flash protection when working on energized electrical equipment. Follow all safety procedures and guidelines when working on electrical circuits. Safety is always the top priority. And always remember the importance of double-checking all connections and ensuring that everything is properly tightened. Loose connections can cause overheating and electrical fires. Regular maintenance and inspection of the electrical system can help to prevent problems and ensure its continued safe operation. The electrical system should be inspected periodically by a qualified electrician. When making any changes or modifications to the electrical system, be sure to update the electrical drawings and documentation. Accurate drawings and documentation are essential for troubleshooting and future maintenance. If you are selling a mobile home, be sure to disclose any electrical modifications or repairs that have been made. Disclosure is required by law in many jurisdictions. When purchasing a mobile home, have the electrical system inspected by a qualified electrician to ensure that it is safe and code compliant. An electrical inspection can help to identify potential problems and prevent costly repairs. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.